Hi everyone, welcome to this new video over Module 9 IPv4 and networking segmentation. The first point is IPv4 Unicast, Broadcast and Multicast. The first topic is Unicast. In the previous topic you learned about the structure of an IPv4 address. Each has a network portion and a host portion. There are different ways to send a packet from a source device, and these different transmissions affect the destination IPv4 addresses. Unicast transmission refers to one device sending a message to one other device in one-to-one communication. A unicast packet has a destination IP address that is a unicast address which goes to a single recipient. A source IP address can only be a unicast address because the packet can only originate from a single source. This is regardless of whether the destination IP address is a unicast, broadcast, or multicast. Okay, we can see that animation of one example to communicating unicasts. I repeat, the message is with this IP sent to this switch, and the switch send the packet to this printer with this IP address. Okay, note in this course all communications between devices is unicast unless otherwise noted. IPv4 unicast host addresses are in the address range of 1.1.1.1 to this netmask address. However, within the range are many addresses that are reserved for a special purpose. This special purpose address will be discussed later in this module. Okay, this is very important. IPv4 unicast host addresses are in the range of IPv4 with this netmask. Note in the animation, notice that the subnet mask for this subnet mask is represented using a slash notion of /24. This indicates that the subnet mask is 24 bits long. The subnet mask in binary is this. Okay. The next point is IPv4 broadcast. Broadcast transmission refers to a device sending a message to all the devices on a network in one-to-all communications. A broadcast packet has a destination IP address with all ones in the host portion, or 32 bits. Note: IPv4 use broadcast packets. However, there are no broadcast packets with IPv6. A broadcast packet must be processed by all devices in the same broadcast domain. A broadcast domain identifies all hosts on the same network segment. A broadcast might be directed or limited. A directed broadcast is sent to all hosts on a specific network. For example, a host on the 172.16.4.0/24 network sends a packet to this IP address. A limit broadcast is sent to this netmask by default. Routers do not forward broadcast. Okay, I need to mark this part. For example, a host on this address mask sends a packet to this address. A limited broadcast is sent to by default. Routers do not forward broadcast. Play the animation to see an example of a limited broadcast transmission. Okay, and we have source and destination. This is the source, and the destination is these all the devices. We can see how this device send a packet to this switch, and the switch send the packets to all ports attached to the switch. Broadcast packets use resource on the network and make every receiving host on the network process that packet. Therefore, broadcast traffic should be limited so that this does not adversely affect the performance of the network or device. Because routers separate broadcast domain, subdividing networks can improve network performance by eliminating excessive broadcast traffic. And the next point is IPv4 multicast. Multicast transmission reduces traffic by allowing a host to send a single packet to a selected set of hosts that subscribe to a multicast group. A multicast packet is a packet with a destination IP address that is a multicast address. IPv4 has reserved this address to this address as a multicast range. Okay. IPv4 for multicast is receive these IP addresses from 224.0.0.0 to 239.255.255.255 address as a multicast range. Hosts that receive particular multicast packets are called multicast clients. The multicast client uses service requested by a client program to subscribe to the multicast group. Each multicast group is represented by a single IPv4 multicast destination address. When an IPv4 host subscribes to a multicast group, the host processes packets addresses to this multicast address, and packets address to its uniquely allocated unicast address. Routing protocols such as OSPF use multicast transmission. For example, routers enabled with OSPF communicate with each other using the reserved OSPF multicast address. With this address, with the device 5 in this case. Only device enabled with OSPF will process these packets with this address as the destination IPv4 address. All other devices will ignore these packets. And the animation demonstrates clients accepting multicast packets. Okay. Source, this is the source, and destination is this. Is 224.10.10.5. Okay. The net mask of these devices is 255.255.255.255 for this character 24. And we have activity, unicast, broadcast, or multicast instructions. Click Start to see a destination IP address. Next, click the host or hosts which will receive a packet based on the address type, unicast, broadcast, or multicast. Click Check to verify your answer. Click New Problem again to get a new problem. Well, and destination IP address, source host, and okay, start. Destination IP address 237. Okay, here, here, only two devices. Check. Correct. You have successfully identified the multicast destination IP address. Is multicast by the group. Any problem? Okay. And check. No problem. Okay. And check. You have not successfully identified Unicast destination. Okay. Okay. No problem. Okay, this is a group. In this case is this and this. And okay, destination IP address. Correct. You have successfully identified the Unicast. Okay, I understand. Any problem? This is a group. Okay. And 5. Correct. Okay. I understand. Very well. In the next point is type of IPv4 addresses. The first topic is public and private IPv4 addresses. Just as three are different ways to transmit an IPv4 packet, there are also different types of IPv4 addresses. Some IPv4 addresses cannot be used to go out to the internet, and others are specially allocated for routing to the Internet. Some are used to verify a connection, and others are self-assigned. As a network administrator, you will eventually become very familiar with the types of IPv4 addresses, but for now, you should at least know what they are and when to use them. Public IPv4 addresses are addresses which are global router between Internet Service Provider (ISP) routers. However, not all available IPv4 addresses can be used on the Internet. There are blocks of address called private address that are used by most organizations to assign IPv4 address to internal hosts. Okay, this is very important. I mark. Not all devices IPv4 addresses can be used on the Internet. There are blocks of addresses called private addresses that are used by most organizations to assign IPv4 address to Internet hosts. In the mid of 90s, with the introduction of the World Wide Web, private IPv4 addresses were introduced because of the depletion of IPv4 address space. Private IPv4 addresses are not unique and can be used internally within any network. Note: the long-term solution to IPv4 address depletion was IPv6. And we have a table with network address and prefix, a request for comments, RFC 1918, private address range. Okay. With the A is the subnet mask, with the 12 is the subnet mask, and with 16 is this subnet mask. Note: private addresses are defined in RFC requests for comments in 1918 and sometimes referred to a request for comments 1918 address space. The next topic or point is routing to the Internet. Most internal networks, from large enterprise to home networks, use private IPv4 address for addressing all internal devices, intranet, including hosts and routers. However, private addresses are not globally routable. In the figure, customer network 1, 2, and 3 are sending packets outside their internal network. These packets have a source IPv4 address that is a private address and a destination IPv4 address that is public, globally routable. Packets with a private address must be filtered, discarded, or translated to a public address before forwarding the packet to an ISP. Private IPv4 address and network address translation (NAT). And the image we can see, this packet has a source IPv4 address that is a private address. I will translate it to public IPv4 address using NAT. Okay, I remember what is NAT, network address translation. Okay, this is the router. Okay, network 1, network 2, network 3. Okay, this is the subnet mask, and subnet mask. Okay, this is a private network, and the router will have to translate the IP private to IP global. Before the ISP can forward this packet, it must translate the source IPv4 address, which is a private address, to a public IPv4 address using network address translation (NAT). NAT is used to translate between private IPv4 and public IPv4 addresses. This is usually done on the router that connects the Internet network to the ISP network. Private IPv4 address in the organization's intranet will be translated to the public IPv4 addresses before routing to the Internet. And we can see an activity pass or block IPv4 addresses. Instruction: decide to pass or block each IP address depending on whether it is public, the internet, or private, a small local network. Click Start to begin, then click on Air Pass or Block. Okay, start this pass. And this pass block and block pass you have successfully identified public and private IP addresses. Excellent. Close. The next topic is special use IPv4 addresses. There are certain addresses, such as the network address and broadcast address, that cannot be assigned to host. There are also special addresses that can be assigned to host, but with restriction on how those hosts can interact within the network. Loopback addresses. Loopback addresses with this address or this address are more commonly identified as only 127.0.0.1. These are special addresses used by a host to direct traffic to itself. For example, the ping command is commonly used to test connection to other hosts, but you can also use the ping command to test if the IP configuration on your own device as shown in the figure. Note: you will learn more about the ping command later in this course. Okay, ping the loopback interface. Okay, only enter this command ping with this loopback address, or you can use this is the same ping command with this address loopback. And link local addresses. Link local addresses, this address or this address, are more commonly known as the automatic private IP, addressing IPIPA addresses or self-assigned addresses. They are used by a Windows client to self-configure in the event that the client cannot obtain an IP addressing through other methods. Linked local address can be used in a peer-to-peer connection but are not commonly used for this purpose. Okay. The next point is legacy classful addressing. In 1981, IPv4 addresses were assigned using classful addressing as defined in RFC 719. Assigned numbers. Customers were allocated a network address based on one of three classes, A, B, or C. The RFC divides the Unicast range into specific classes as following. Class A is this, designed to support extremely large network with more than 16 million host addresses. Class A uses fixed/A prefix with the first octet to indicate the network address and the remaining three octets for host addresses. More than 16 million host addresses per network. The next class is Class B. with these addresses designed to support the needs of moderate to large size network with up to approximately 65,000 host addresses. Class B used a fixed /16 prefix with the two high-order octets to indicate the network address and the remaining two octets for host addresses. More than 65,000 host addresses per network. And the last Class C with these addresses designed to support a small network with a maximum of 254 hosts. Class C used a fixed /24 prefix with the first three octets to indicate the network and the remaining octet for the host addresses. Only 254 host addresses per network. Note: there is also a Class D multicast block consisting and a Class E experimental address block consisting of these addresses. At the time, with the limited number of computers using in the Internet, classful addressing was an effective means to allocate addresses, as shown in the figure. Class A and Class B networks have a very large number of host addresses, and Class C has very few. Class A networks accounted for 50% of the IPv4 network. This caused most of the available IPv4 addresses to go unused. Okay, I need to translate this part. Okay, in the mid of 90s, when the introduction of the World Wide Web, classful addressing was deprecated to more efficiently allocate the limited IPv4 address space. Classful address allocation was replaced with classless addressing, which is used today. Classless addressing ignores the rules of Class IBC, public IPv4 network address. Network address and subnet mask are allocated based on the number of addresses that can be justified. The next point is a segment of IP addresses. Public IPv4 addresses are addresses which are global routed over the Internet. Public IPv4 address must be unique. Both IPv4 and IPv6 addresses are managed by the Internet Assigned Numbers Authority (IANA). The IANA manages the allocates blocks of IP addresses to the regional Internet registers. The five RAREs are shown in the figure. Readers are responsible for allocating IP addresses to ISPs who provide IPv4 address blocks to organizations and smaller ISPs. Organizations can also get their address directly from RIR, subject to the policies of RIR, Regional Internet Registers. Okay. Africa, Asia, North America, Latin America, in Europe. And we have activity, public or private IPv4 addresses. Instruction: click public or private below each address to choose the correct network type. Okay. This is private, 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 public, public, private, and this is, I think it's public, I don't remember. And this is private, I think so. Private, okay. Private, public, 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 private, private, and private. Okay, again, this is private, private, public, 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 private, private, private. No, it is public or private. Okay. Okay, that's right. Finish with check your understanding types of IPv4 addresses. Question 1. Which two statements are correct about IPv4 addresses? Okay, okay, submit. That's not right. IPv4 addresses are assigned to devices. Okay, reset. Okay, that's right. Private IPv4 addresses are assigned to devices within an organization internet network, and any organization, home, school, office, company can use these addresses. Question 2. Which two statements are correct about public IPv4 addresses? Choice 2. Okay. And question 3. Which organization or group of organizations receive IP addresses from IANA and is responsible for allocating these addresses to ISP and some organization? That is this. Okay. Okay, this is all for this. See you in the next one. Bye.